Okay, so let's work this problem. This one's 640 in your textbook. You'll notice from the description it's only asking for three forces, CD, CF, and CG. And if you identify those, I'll just put a little squiggle here, CD, CF, and CG. Where's CG? Right here. So this is not necessarily a direct application of the method of sections as we've talked about before. It could be a combination of both method of sections and method of joints, and we'll look at it that way. Or actually, we could do two sections, however you want to do it. I think I will look at a section here and try to identify these two forces, and then once we finish that, we'll go back and we'll look at CG and see how we can handle that. We could go to do a method of joint at C because we would have GF, we have two unknowns, we could solve it that way, or I could make an additional cut. So we'll explore both those options. First thing I want to do though is if I make a cut here, I have to decide whether I want to work the left side or the right side. Not really a big advantage to either, but I'm going to choose the right-hand side. There's only one reaction at E, whereas on the left-hand side there would be two. So I'll choose the right-hand side. So the first thing we need to do is find this reaction at E. So let me go ahead and indicate that I've got a force acting here. I'll call it EY, and I would have an additional force AY and then AX. I'm going to kind of cheat a little bit and not redraw the whole structure as a free body diagram for my reactions and see if I can solve for EY just straight up from here. So I'll sum moments, use right-hand rule for my sign convention. And where should I sum moments if I'm trying to get EY? Looking at the entire structure as a rigid body. Sum moments at A. So let's sum moments at A, set it equal to equilibrium. So about A, the 2 kilonewton force is at A, creates no moment. So I have 1, 2, 3, 4 forces. All 4 of those applied forces are creating negative moment according to my sign convention. So I'll just go down the line and do each one individually. So I have 4 kilonewtons times 5 meters minus 4 kilonewtons times 10 meters minus 5 kilonewtons times 15 meters minus 3 kilonewtons times 20 meters. So I've counted for all my forces, and then my reaction creates positive moment, and it also has a 20 meter. So we should be able to solve for EY. Whatever that is. I say it's 7.5, but I'm just guessing. You guys got it? Mr. Dean, what did you get?
Oh, I got 9.75.
9.75? Anybody else get that?
Yeah.
9.75? It should be positive. Okay? So now let's go and cut and look at the right-hand side. So I'm going to look at my cut surface. So I'm going to have to redraw I'm going to draw a free body diagram for that particular setup. So there's the right-hand side. This would be the force in CD. This would be my force in CF. And this would be my force in GF, something I don't really need right now. And then acting at D, I have a 5 kilonewton force. And then acting at E, I have a 3 kilonewton force. And then my reaction, which I've just solved for, which is 9.75. Let's see, I'll go ahead and draw on my geometry. I probably need the components of this guy for sure. It looks like I have a rise of 3 over a run of 5. You see that? Not a very convenient one for us, but it looks like it goes 3 vertical for 5 horizontal. If I did want the components of GF, it would be a 2 to 5 slope. Everybody see that? Any questions about that? So where should I go and do my work? There's F and D, and this is E. So I want to try to find, remember, let's not forget the problem, I want to find CF and CD. Those are 2 of my required. So can I find a way to do that? How can I find CF, one equation, one unknown? Where would be a good place to some moments to find CD? Well, look at my other unknowns, CF and GF. Do they have anything in common?
F.
F. So I think that's a good place to start. So let's sum moments at F. When I do that, CF and GF pass through F, create no moment. This 5 kilonewton force passes through F, creates no moment. So I'm just going to have CD, which creates a positive moment. What's the moment arm between F and this line of action CF? It should be this little height here, which is 3 meters. Then I have this composite set of forces. The 3 kilonewton force is creating negative moment about F, and the 975 is creating positive. I could sum these together and get a resultant force, but I'll do them separately right now so you can see them. So I'll have minus 3 kilonewtons, and the moment arm is the distance from F to E, which is 5 meters, and then plus 9.75 kilonewtons, and it has the same moment arm. Kind of squeezed it in there, sorry. So what is the force CD? It looks like it's going to be negative. Anybody get an answer to that?
11.25.
I'm sorry, what, 0.25?
11.25.
Anybody else get 11.25?
Yes.
Yep, and that's negative, right? So 11.25 kilonewtons. 1 down, 2 to go. So I'll come back over and say, okay, I got that one. Now, how can I get CF? Is there a way I can find CF all by himself? This guy right here? Well, let's see. CF has a Y component, but so does GF. So summing forces in the Y direction won't help. They all have X components, summing forces in the X component. I mean, it would work. I would get 2 equations and 2 unknowns.
We could do GF if we took the moment about C.
About C.
Right.
We could, but I don't want GF. I want CF. So I picked this problem because I wanted to show you something. If I project this line of action back in space, it will be concurrent with the other force. You see that? Some point P. Why did I choose that point P?
So you could find CF.
CF, CD passes through, and GF, so I just have this guy.
But how do you find the like perpendicular distance between?
Well, I'm glad you asked that, because the next point would be to allow this force to slide up on its line of action, and I'll let it slide up to this point, which is actually point C, and then I'll look at its Y component and its X component. Now, which of those components would create moment about P? Just the Y component. And then the distance would be easy. It would just be the distance from C to this point P. So how do I find this point P? I just need to project this line back. All right, so this line, for every 5 feet I go over, I'm dropping 2, right? So when I go another 5 feet over, what would I be here? 1. When another 5 feet over, I'd be minus 1. So it looks like this distance here is just going to be 5 divided by 2. Does that make sense? So obviously it's not the scale, but the distance between each of these is 5. I go from here to here, I drop 2. I go 5 more, I drop 2. If I go half of 5, I drop 1. So the distance from E to this new point P is 2.5 meters. So now I can sum moments about this point P. So when I do that, my 3 applied forces will create moment. CD and GF create no moment, they pass through P. And all I have to do is find the Y component of CF, and I'll know that. So first I'll account for all my forces. The forces at the top are creating positive moments, so I'll have 5 kilonewtons. And what's the distance? It'll be 5 plus 2.5, 7.5 meters. Then I'll have positive moment created by the 3 kilonewton force. The distance from E to P is 2.5. The same is true for the 9.75 force, except it's creating negative moment. Taking care of all that, now I just need to get the Y component of CF and then calculate its distance. Now the way I've drawn it here, the Y component is creating negative moment. And what would be the Y component? It would be this part. Let's see, 3, 5 would be 9, be 34. Square root of 34 is the hypotenuse. 5 squared plus 9 squared. So that would be 3 to the square root of 34 FCF, that's the Y component. And then what's its distance? 5 plus 5 plus 2.5, 12.5. So we should be able to solve for CF. Somebody check that out for me. It looks like we're going to get, I think we're going to get a positive number. Not sure. Anybody get a number yet?
I got 3.21, but I don't know.
I got 3.21 also. Anybody else get 3.21? Mr. James, did you get 3.21? Mr. Coleman is still punching away.
I just cleared it.
Oh. It's kind of a long calculation. I think it, well, I don't think. I'm thinking it's 3.21.
Wait, so what is it? Square root of 34?
on the bottom?
Yeah, is it hard to see? Yeah, that's the square root of 34.
But why is it that? I see why it's the.
That's the hypotenuse of a 3, 5 triangle. 5 squared plus 3 squared.
Okay.
What did you get for your answer?
3.21.
That's right. Well, mine's negative.
I think I got positive. Did you get a negative?
Positive too.
I got a
might
positive.
have done a sign.
Oh, okay. I like that. So we got that one. Good question.
I mean, I was just thinking that you could find FGF and then you could sum all the.
Oh, there's another way to do it. I wanted to show you this way because I wanted you to see that you can find a point
In space.
off in space somewhere that could work for you.
It's interesting.
So now at this point we've got 2 of the 3. We have to now go back and figure out how we're going to find CG. Now the way I've worked it, I don't have GF, although I could get GF now if I wanted to. Is there a way to get CG without that information? I think we're going to need it. I'm just looking at trying to, if I make a cut here, all the forces are concurrent, so moments aren't going to help me any. So I'm going to have to sum forces and sum. So if I do a method of joint at G, I'm still going to need this value. So it looks like we're going to have to get that intermediate value even though we don't need it. I can't think of another way to cut it. Every other way I can see to cut it is always going to go through 1, 2, 3, 4 or 1, 2, 3, 4. So let's go ahead and get GF. Now how can we get GF? One equation, one unknown. I know my free body diagrams got really complicated, but is there a way to find GF without including these previous results?
The moment about C.
The moment about C. Right? Because CD and CF both pass through C. So let's do that. Let's sum the moments about C. So when I do that, my 1, 2, 3 forces will kick in with moment arms. CD and CF pass through there. So now I have to worry about GF. Well, in a similar way, remember, GF exists anywhere on this line of action. So I'm going to let it slide down and exist at point G. Now why do I do that? Because when I'm at G and I'm looking at the moment about C, all I need is the X component. And that distance is really easy to find. So let's first account for all the forces. The forces on the top, summing moments about C, are going to be negative. So I'm going to have minus 5 kilonewtons times 5 meters, minus 3 kilonewtons times 10 meters. And I've got my reaction force. That's creating positive moment. The force is 9.75 kilonewtons, and the moment arm is 10 meters. So now I need the X component of this guy, and then its moment arm will be the height between C and G, which is 5. So what is that? Looks like I need 5. This is a 2, 5 triangle, so it's going to be this component is going to create negative moment. It'll be 5 to what? Well, it'll be 5 squared plus 2 squared.
Square root of 29.
Square root of 29. And that'll be force GF. So that's my X component. And then the moment arm is 5 meters. So I should be able to find the force GF. 5. So that should be 5, 6, 18. $12 something? No, I don't know what it is. Less than 12 something. Anybody get it?
30. No, I must be wrong. I got negative 32.85. I think that's right. 25 plus 30.
Nobody's got it yet? I brought my calculator. Maybe I should do it. I got 9.15. Anybody else get 9.15? Should be tension. Should be positive.
I got 9.5.
That makes me feel good. I haven't forgotten how to use my calculator. Hopefully that's right. So now to finish the problem, I would just have to take that information and worry about G. Let's do it real quick. So if I came here and did a joint at G, let's see what I've got. I would have the force in CG, that's the one I'm looking for. Then I've got this force, GF, which I know, and I've got this force, GH. And these have the same slope. Let's see, it's 2 to 5. Now this looks pretty daunting, but I may let you guys finish this for homework. But what I would do first is I would sum forces in the x direction. Now you can see their x components are the same. They're going to be 5 over the square root of 29, same thing we did before. And since they're equal and opposite, when you do that problem, you're just going to find out that GH and GF are equal. And once you know that, you should be able to solve for CG. Right? Because remember, don't forget, we know this value. We just found it. That means we now know this value. So then we're just left with one unknown. So the way to finish the problem would be to simply sum the forces in the y direction. And if I did that, I would have the force CG acting up, and then I would have plus the y component of each of these, which is 2 over the square root of 29. And that would be the force in GH, and then plus the other one, 2 over the square root of 29, the force in GF. But remember, they're equal. So we should be able to solve for the force in CG. So take our value of 9.15, multiply it by 2 times the square root of 29 times 2, and that should be GF. And GF looks like it's going to be negative. Since GF is positive. And what is that? Anybody got that?
6.80.
6.80. So this was more of a demonstration. I wanted to show you that you can combine both method of sections and method of joints to find selected elements. Also, an additional feature was to show you that you can find points off the free body that might help you do the work. Is this a valid problem for the exam? No way. Right? It just took us 26 minutes to work this problem. If I gave you a test with 2 problems on it, and this were one of them, well then maybe. So I just wanted to, this is more of a problem to show you, to extend your capabilities. It's probably not a good problem for the exam. More like the one we just had previously is more typical, a more direct application. Any more questions about this? I'll stop this one.